Simultaneous equations. These are also called system of equations. So there are different methods to solve simultaneous equations. Let's see what are those methods. These are substitution, elimination, graphical, matrices, and calculator. What's the substitution method? Let's see with a simple example. We have these two equations. We call these equation 1 and equation 2. To solve these equations using substitution method, we have to make either x or y the subject of the equation. Right now I am taking equation number 2 and make y as a subject. For that I have to shift y on the right hand side and 16 on the left hand side. This will give me the equation and here y is the subject. Some people prefer to write this equation like this. Let us call this equation number 3. All these red color equations are same. They are basically equation number 2, which after some manipulation it has become equation number 3. So from onward we will use equation 1 and equation 3. Now we will use equation 3 and we will put the value of y from equation 3 into y of equation 1. The value of y in equation 3 is 4x minus 16. So we plug in equation 1 and after some simplification, and in this equation 3x and minus 16x, they are like term, they will give us minus 13x, and when shifting 64 on the right hand side we will get this result. And here we will divide minus 39 by minus 13 and the value of x is 3. So this is our first part of the solution. Now to find the value of y, we will put this value of x in equation number 3. And after some simplification, it will give us the value of y, that is minus 4. Therefore the value of y is minus 4 and we have the solution. X is equal to 3 and y is equal to minus 4. Now let's move to the second method, that is elimination method, and see how to use this method to solve simultaneous equations. We have same two equations, equation 1 and equation number 2. To solve using elimination method, we have to eliminate either x or y Right now I am interested to eliminate y. To eliminate y, both y should have same coefficients but with different signs. But right now here one y has coefficient 4, the second has coefficient 1, but they don't have different signs, they have same signs. To make both the coefficient same and with different sign, I will multiply equation number 2 by -4, and this will give me minus 16x plus 4y is equal to minus 64. Now I will use this equation with equation 1. Now you can see the coefficient of y, they have same coefficient 4 and their signs are different. The next, what we have to do, we have to add these equations. Mm, 3x minus 16x, this will give me minus 13x, and the first y is minus 4y and the second is plus 4y. They have different signs but same coefficient. These will be cancelled out, so we have minus 13x is equal to minus 39. This will give me x is equal to 3. So this is our first part of the solution. Now we will plug in this x in any one equations, either in equation 1 or in equation 2. Right now I am going to put this value in equation number 1. So after simplification, this will give me the value of y, that is y is equal to minus 4. So we have the same solution as we found in method 1. X is equal to 3 and y is equal to minus 4. Great. The third method is graphical method. So let's use this method to solve same two equations. This is equation 1 and equation 2. To solve them using graphical method, we have to draw the tables of equation 1 and equation number 2. So to find the table of equation 1, I will put different values of y to find the values of x. Let me try. If y is 0 in equation number 1, this will give me x 25 over 3. Not interested in fractional values, so I will try some other. Let me try y is equal to minus 1. After solving equation 1 by putting y is minus 1, this will give me x7. That's great. These are the whole numbers. In the same way, I will put y2 this will give me x11. And in the same pattern, I will find and I will draw the table of values for equation 2. Once we have drawn the tables of both equations, next is we have to plot each table on the Cartesian coordinate system. This is x-axis, this is y-axis, and these are the grid lines. So let's plot the table of values of equation 1. The first value is 7 minus 1, second is 11, 2, and then draw a straight line from these 2 points. So this is the equation of the first line, or this is the graph of the first equation. Now plot the points of values of second table and join these points with a straight line, and this is the graph of the second equation. These two lines intersect at this point, and this is called point of intersection. And let's see the coordinates of this point of intersection. These are 3 and minus 4. So the solution of the equations are x is equal to 3 and y is equal to minus 4. The same solution. Great. Now the fourth method is the method of matrices. Let's see how to use this method. We have same two equations, equation 1 and equation 2. The first step is to convert these equations in matrices. So we have one matrix for left hand side and the second for right hand side. The next is to convert the left hand side matrix into matrix of coefficients and matrix of variables. Here in this matrix we have to find the value of x and y. To find value of x and y, we have to shift matrix of coefficient on the right hand side. And remember, the matrix of coefficient is on the left hand side of matrix of x and y, so it should be on left hand side of matrix 25 and 16. So shifting the matrix of coefficient on right hand side, it will give us the inverse of the matrix, and now we have to find the inverse of the matrix. The formula for inverse of the matrix is 1 over determinant of matrix times adjoint of the matrix. And this part in the rectangle is basically 1 over determinant of the matrix. The determinant of the matrix can be calculated by multiplying these entries minus product of these entries. And this matrix in the red square is adjoint of matrix. This is calculated by switching these entries. We have switched the places of these entries and then changing the sign of these entries. So we have calculated the matrix, inverse of the matrix, just simplification. Once we have calculated the inverse of the matrix, the next is we have to multiply these two matrices by applying the multiplication rule and just doing some simplification. This will give us the matrix of variable x and y. Therefore, the value of x is 3 and the value of y is -4. The same solution. Great. Now let's move to the method number 5, where we will use calculator. We will have the same equations, equation 1 and equation 2. We have to use, in this method we have to use the coefficients of these two equations. So this is our calculator. Press this mode button and see here at number 5, these are equations. Press 5 and these are different types of equation. The first equation is equation which have two variables x and y. And this is our required equation. We will use this equation 1. Second equation is equation with three variables x, y, z. And the third equation has x squared, which is quadratic equation. And third has x cubed, which is cubic equation. We will have the first one because we have variable x and y. Press 1. Now we are going to put the values of the coefficients of equation 1. The first coefficient, that is 3. Press 3 and then equal sign. Then press second coefficient, which is -4, and then press enter button. And then 25, and press enter. Now we are going to put the coefficients of second equations. Remember, every time you have to press enter. Once you have entered all the coefficients and constants, you press enter again. This will give us the value of x, which is 3. Press enter again and it will give us the value of y, which is -4. So we have the solution: x is equal to 3,